I think this is pretty obvious to everyone here. The pandemic started a trend in adoption for cloud, and that's just accelerated post-pandemic. And at the end of last year, Qualys did a very interesting survey. It's called the Total Cloud True Risk Insights White Paper, where we really tried to assess sort of the perceived risk and the actual risk of these enterprises as they're moving to the cloud. I think, as was also mentioned in the previous panel, that sometimes organizations are just jumping really quickly into the cloud and really totally sort of understanding the risk that that poses sometimes as an afterthought. So here are some data, quite interesting, I think, that's in this report that sort of highlights some of the challenges enterprises are facing as they migrate to the cloud, move workloads to the cloud, or just if they're even cloud native, trying to get their handles around this really new environment, new API-based, API-first environment. And what you're seeing here is that one of the first things enterprises try to do is they try to assess what is known as their posture. Am I using this correctly? And in our industry, we have these CIS benchmarks from the Center for Internet Security that gives best practices. And then even the cloud vendors, AWS, Azure, Google, they have their own best practices as well. But what you can see here is that in this enthusiasm to adopt the cloud, we're seeing a lot of failures of these best practices. And in fact, it's fairly large. And this was a little bit of a surprise that people have these tools. But I think the dynamic nature of the cloud, as well as the novelty, is leading to some of these situations with still trying to get your hands around some of the misconfigurations that you have. Secondly, we're seeing that there's a very large number of vulnerabilities that are still unpatched in the cloud. And the number is pretty high, 70%. And they take very long to remediate. And for those that are familiar with the situation in on-prem, you can see that some of the challenges there are also translating into the cloud. And finally, what was also a bit of a surprise to us is the kind of attacks that we're seeing getting into the cloud. We see a very large number of crypto miners. So it's not just about sort of people attackers going after your data, but your compute is really interesting for the attackers as well. So you can see that there are these 3 different types of issues that affect your risk posture in the cloud. Now I'm going to talk about 2 of them and then lead into kind of where I think some of the very interesting challenges are. First, misconfigurations and vulnerabilities are very important. That's part of basic hygiene. So you've got to make sure that the misconfigurations that you have, for example, you don't want disks remaining unencrypted. If you have assets that are exposed to the public internet, should they be, just make sure that they are. If you have secrets that are lying around, like API keys or passwords, you have to make sure that those are handled correctly and not just exposed to everyone to see. Finally, vulnerabilities. There's a very large number of them. You have to make sure you can prioritize those and fix those. But I think this is where a lot of the attention gets focused today because the novelty of the cloud is still there. But sometimes in risk, it's often in risk assessment for clouds, the whole notion of dynamic threats, the active threats are often overlooked. And what that means is that if you have vulnerabilities and you have assets with similar types of vulnerabilities and some that are exposed to the internet, they need to be, and there's active attacks on them, they need to be prioritized in terms of what to do and what to fix before something that's deep within your organization, perhaps not exposed to the internet, perhaps not facing something, an external attack. And some of the things that I'm showing up here include beaconing activity like C2 going out to a malicious server, malware already being downloaded, crypto mining, or unauthorized communication, something like brute forcing. Now, one of the things that people have not really focused on is that threat detection itself. The active threat is a hard problem. And it's only going to get worse, as I'll show you later on in this presentation, is that just in the case of malware, we see 1 million new every single day, very complex variants, and they try to evade sandboxes that try to create signatures, and threat intelligence also can't keep up. And I think some of this stuff is known, and I think we've seen some attempts at trying to make some of this dynamic analysis a little bit faster and a little bit more effective. But even then, we're seeing that just trying to get signatures out through any of these sandboxes, pretty well known, very difficult to sort of make this process scale. So that's just kind of, I think, where we were, maybe I would say, a year ago. But now we're beginning to see the application of generative AI by attackers themselves, and it's very varied. And some things that I hadn't expected in terms of how it's being used for reasoning and logic is going to be surprising in my view. So one of the first things I talked to someone who's very knowledgeable is that one of the things that generative AI can do is it can write. So it's not an entity, it's not a sentient being, but it can write in a way that can fool us into thinking that it's human. And so you will see lots of very sophisticated phishing attacks. That's just going to happen. There's just you're going to see remarkable social posts claiming that somebody is, or an entity is something that they are, that they really aren't. But I think you're going to see some very complicated and sophisticated malware creation techniques that are going to take snippets that sometimes in the past perhaps you have not had things that can execute, but it's a file that gets downloaded initially and then unpacks itself. But you're going to see very complicated sort of malware variants that get created. And you'd also see automated techniques for exploiting vulnerabilities. In LLMs, I think we're really at the inception of this, and this stuff is bound to happen. We're beginning to see some of it. It's just going to get more and more complicated over time. And so at the end of the day, with this proliferation of complexity, there's no way you can really attack this threat problem without using AI in some form. Now I'm going to give you some ideas because it's not all bleak, because sometimes it's a cat and mouse, fighting fire with fire kind of situation. But I think the communities are large enough that we have an opportunity to stay ahead of the game, be very vigilant about how these attack scenarios are being created, and create very generic models. And I'll give you some very interesting perspective on when we were looking at this problem, and we have been for quite a bit of time, just with deep learning. We learned a lot about, it's just not the quantity of data, but it's how you train the systems, the diversity that you have in your data set that helps you detect extremely novel things. And it's going after this novelty. I think that's going to be the very big challenge for us as a defense industry to defend against some of these attacks. So I'm going to give you some perspective on some very interesting things that we've done and sort of a potential for where some of this stuff might head into the future. Now, there's a very particular challenge in the cloud, as you'll see in my presentation, is that the speed of detection matters. So workloads in the clouds can often be very, very transient. In our very large customer base that Qualys has, we have customers that have very large number of virtual machines and workloads, some of which that are long running, that they protect in a certain way, and some that are transient, that come and go, can be minutes, hours. So any threat detection techniques that can't be done quote unquote very fast or instantaneously really leads you to the point where it's just going to proliferate very, very quickly. So anything that you build has to be very accurate from a detection perspective, and it has to be fast. And these two things, I think, are now possible. A few years ago, they were not. Machine learning systems, AI systems, the inference part of it always had to be fast. Wasn't that quite that fast in cybersecurity, but we've reached a point where we're able to do high-quality inference at high speed. And these techniques, at some level, need to be able to learn, whether it's fully self-learning or some degree of guided self-learning, which is where we are today, is kind of what I think is necessary. And signatures won't cut it. And now let's take another look at another problem. We've talked about the speed and the accuracy. The cloud, one of the things that's happened, we've always had sort of on-prem agile development environments, but with an API-based approach in the cloud, things just go really fast. All the way from development to placing it in a registry and then being plunked out and started to run, whether it's a container or a virtual machine. Things are just going really fast these days. And I think this API-driven approach also makes this faster. People have gotten more used to this whole life cycle of application and development. And so you have multiple places in which you need to protect your workflow, and what's sometimes called the interest shift left, which is going into the development part of things. So heading towards where things are getting built and shipped by the mechanics, and then put in a place called a registry before it gets shunted off to be run. And all of these points are places where you can potentially inspect and improve things. So AI will be used throughout this life cycle. I think we're just beginning on some of that. I think you've seen a lot of AI in these dynamic systems. This is kind of what we've done for quite a bit. But we've actually now sort of spread it throughout, because you can really be effective in many, many different parts of the development lifecycle, as well as runtime. So you will see AI being used for mass scale malware scanning of registries, embedded in some of these tools that are helping you write software as well. What some people call co-pilots. And you'll see more and more sophisticated runtime monitoring techniques getting developed, particularly in the light of some of the very important attacks that I think, and complex attacks that are going to be generated with generative AI. Now, I've really talked a little bit about this maturation of deep learning, which is, in some sense, the core of some of the technologies that are used for generative AI. And you'll see a lot more data that gets generated and becomes available. So I think one of the things that's going to limit building these effective defense systems is going to be curated data. And as I pointed out, one of the really big learnings that I've had in building and using AI for cybersecurity, particularly for defense, it's just not, I mean, people always say, just put all the data in and magic will happen. It's rarely the case. Curation of data for training in cybersecurity for effective defense is a hard problem. And understanding the relation between data elements and the point in which you operate is extremely important. And as I said, diversity is one of the most important things that has helped build better systems. So I'm going to talk a little bit about and give you some examples of some of the things that we found very, very useful. So in the case of malware detection, as I said, all the way from scanning registries, what you're going to see often as you look at these registries and this whole area of malware is that you're going to have lots of hashes with many, 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 many variants. And some are really mutated significantly. And in today's world of development, these are going to show up in containers and then thrown into your registries for then being executed for malicious purposes. So this is one area where it's possible with these new techniques to scan at very high volume. So the speed of this malware detection or threat detection is not just important in runtime, where clearly, as things are running, you don't want to disturb workloads. But even in the development process, we're seeing customers on a daily basis have fairly large number of containers, for example, that need to get scanned. And they need to get those scanned effectively before they're running and in a timely fashion. So you can't have this taking one day to run. You just don't have that time. It has to be really, really snappy. And so this technique is very broad. It goes all the way from registry scanning to your runtime. If something gets downloaded, you will be able to catch it. Now, that's one aspect. The other aspect where we've seen quite a bit of good results is actually by monitoring network traffic and looking at different kinds of very stealthy attacks that, for example, beaconing attacks, where you're able to correlate a variety of different factors to make sure that, for example, it's periodic and it's malicious. And that's also something that we've had very good success with, is trying to be able to narrow down the focus of some of the attacks. Now, the techniques that I'm talking about here, like malware, stealthy beaconing, and a variety of others, we've had very, very good luck with supervised machine learning. And of course, there's another part which is doing anomaly detection with unsupervised, which is also very, very effective, which you've also had good use of as well. But all of these things require good curated data, a good understanding of the problem domain and the attacks that are going to get generated. And I think that's one of the things that I think it's also very useful. In some of these areas, we've had good sharing of data. As you know, there's a database like VirusTotal and others where folks have been able to share data, and that data sharing has really been very effective in helping organizations develop defenses. So I'm hoping that as the attack landscape, gets really, really complicated, that we have, novel sharing databases where we are able to share data for different kinds of malware, different kinds of phishing attacks, things that are trying to exploit vulnerabilities. Because once we start sharing that data, once we work together to curate that data, we will then be able to stay ahead of those that are really trying to get in and cause damage to enterprises. So I think it's an exciting future. And I think we're at the early stages of a lot of what's going to happen here. And what I would say is that generative AI will change the game. I think we're really just at the tip of the iceberg on what is happening. We're going to start seeing things. And I think it's unfortunate, but sometimes it's the attackers that force us into a situation, and sometimes are the earliest users of some of these tools that force us then to be more innovative, forces us to collaborate to then defend ourselves. But the good news is that I think generative AI will be used extensively in defense, and I think it's just beginning to get to that point. There's certain things that need to be developed quite a bit, particularly on the side of logic and how it can do analysis, rather than just being able to handle pure text and writing the next great American novel. There's some of that that'll have to evolve, but a lot of people are working on that. And you will see significant improvement in threat detection, in SOAR, and in remediation. And another area that I didn't talk about much is also being able to explain what is happening, because again, it comes back to the writing piece where generative AI will be a good thing. So I think we'll have a much better sense of the systems we've built and the activities that are happening in the enterprise, because the explanations are going to get significantly better as well. And you will see a lot of stuff at the back end, fixing, remediation. And that stuff also requires good writing, good explanations, good workflows. Those things I think are going to be much better automated very, very quickly. It's the harder problems of the attack, like malware and automated threat detection, that remains a tougher challenge. But I think we're thinking that this simple automation of workflows will get fixed quickly. But that's the big one. And that's where I think we as an industry need to focus, participate in data sharing, to enable the industry to build better systems to protect against the nefarious entities that are out there. A lot of the stuff is in our Qualix TrueRisk Enterprise platform. And if you want to learn more about the platform, I'm putting this up on the screen. I'm happy to talk to anybody here. I'm going to be here later as well. And if you want to talk to me about any of our experience in AI, thoughts about what's happening in the future or the products that we do, anything is fine. So look forward to talking to you. Thank you very much.